All right, so we're looking for Chapter 3, Part 2 review here. So it's the second half of the cumulative review in the back there for the chapter. When we look at this, we're trying to find the minimum and maximum values for the objective function given below. So I'm going to first start out by rewriting this cost function or objective function, however you want to refer to it. And then from there, I'm going to roll into my first constraint. So the first constraint here, I'll do in orange. And it's saying x is greater than or equal to 0. If x is greater than or equal to 0, it means this thing's going to look like a vertical line. It's going to go right through x equals 0. So again, not an awesome line here, but there we go. And then I'm going to be shading to the right. Since I'm greater than, I'm going to be to the right. Next one is y is greater than or equal to 0. If y is greater than or equal to 0, the same sort of deal, except for now it looks like a horizontal line at y equals 0. My best attempt at a straight line, and I'll shade above that thing, a little squiggly line here because it's greater than, y greater than 0, so shade above. And the last one here, I might want to do a little bit more work to it to make it a little bit nicer. So here, I will subtract 4x, so we're going to say 5y equal to negative 4x plus 20. My next move is to divide by 5. Divide by 5. So this thing is going to turn into y is, and this should have remained less than or equal to, my bad. So y is going to be less than or equal to. The sign does not change. We did not multiply or divide by a negative. So this is going to stay the same. And now I've got my negative 4/5 x plus 4 here. So I'm going to go to positive 4, 1, 2, 3, 4, fill in my circle, and then I have two options. One that I can go down 4, right 5, which will put me right here. 1, 2, 3, 4, 5. Or I could be going up 4 and to the left 5. Again, I have another bolded line because these things are all less than or equal to or greater than or equal to. So something like this. And now at this point, I'm going to see, okay, so less than, shade below. So now I'm going to say, okay, well, where's my actual bounded region here? So these are each constraints, and where does it box me into? It boxed me into here, to here, to here. Okay, so these are my 3 points that define my constraints on this function. I'm going to try and like fill this in without making it too crazy. Just to represent, again, that's like our double, triple shaded region there. That's what we know. And now I'm saying, okay, well, let's find each of these points. So for the first one here, we'll call it 23-letter word. Let's do dog. So we got D, O, G. Point D is 0, 0. Point O is 0, 4. And point G is 5, 0. So from here, I'm going to evaluate in my cost function, my objective function here. So I'm going to take it and just copy it down a little bit so it all fits together nicely. I'm going to plug in for each of these different items. So the first one here is going to look something like 5 times 0. So 5 times 0 plus 2 times 0. Shocker, gives me 0. This looks like a pretty good candidate for a minimum, but we don't know that yet. Next one here, I have 0, 4. For 0 times 5 gives me 0. 4 times 2 gives me 8. Perfect. Next one here, 5 times 5 is 25. 0 times anything is 0. Oops, I don't know why I put a comma there. Be a plus. 0 equals 25. So now I'm asking you to find the min and the max. Well, the min is at 0. For the max, we'd say that one is 25. So that allows us to finish solving for this problem. Any questions here?
How do you if it's a straight line?
How do I draw the straight line?
No, how do you straight or a dash?
Oh, how do I know if it's a straight, like a bold line or a dashed line?
Yeah.
Yep. So that depends on whether it's less than or greater than, or if it's a less than or equal to, greater than or equal to. So see the little line underneath here?
Yep.
That's what's telling me it's or equals to. So like if I was talking about people and I said, okay, I just want people taller than Mr. G, right? If you're 6 foot, 6'1", whatever, that's fine. I'm 5'11". So anyone taller than me, yeah, you're taller than me. But could I say another person who is 5'11" is taller than me? I can't say that, but could I say they're taller than or equal to me? Yeah, absolutely, right? And so what that means is we can include those points. When we include those points, we draw it as a bold line because it actually includes all the points on the line. The dashed line is telling me get very, very close to those points, but don't actually use them. That's the difference between the two. So anytime I see that little line underneath for the, greater than or equal to, less than or equal to, I'm going to be using a bold line. Good question.
Thank you.
What else we got? Any more for this one?
Where did you get the first equation in blue? The 5y is less than or greater to negative 4x plus 20.
So the first thing I did was I subtracted off 4x. So that's to get us here. And then from there, I divided by 5. So divide each of these by 5. And that's how I got to this point.
Yeah, I was looking at 13, not 14. My bad.
No worries. No worries. Good with this one?
Yeah.
Perfect. Perfect. So we're going to run through super, super similar for 15 here. I'm actually going to copy my cost function because the objective function stayed the same for both of these problems. It doesn't always turn out that way, but sometimes it just gives it to you like 3 or 4 problems at a time. Use this cost function. So here we go. Our objective function. I'm going to try underlining these. They're a little bit small, so please forgive me if I kind of overwrite some stuff. So here I'm going to do the first one, which is x greater than or equal to 1. So that's going to look like a vertical line at x equals 1. It is a bold line. And then since it is greater than or equal to, I'm going to be shading to the right. My next move here is to be doing this chunk. X is less than or equal to 4. So I'm going to go to 4. I'm going to do the same thing, except for instead of shading to the right for greater than, I'm going to shade to the left for my less than. There we go. Y is greater than or equal to 0. This is the same as we did before. Horizontal line right here at y equals 0. Shading above. And then last but not least here, we have y is less than or equal to 9. So I'm going to have another horizontal line here right at y is equal to 9. Pretend that it's a horizontal line and you're not using a mouse to draw lines and you actually were like, a go-getter and you did this even faster too. There's no reason why I don't do it. I just forget it even exists. So looking at this, I'm going to be shading below y is less than or equal to this thing. So there's the bottom part like that. Now, where is my final bounded region? My final bounded region is all of this stuff in the middle here. It's got to be above the light blue, to the left of green, to the right of orange, and it's got to be below that darker purple there. So while, yes, it is all this stuff in the middle, I know that my mins and maxes are going to come from these 4 points here. And I love it when there's 4 points because it allows me to name them M, A, T, and H. So now I'm going to look at these different points, M, A, T, and H. My M coordinate is 0, 0. My A coordinate right here is going to be 1, 9. My T coordinate here is going to be at 4, 9. And my last H coordinate here is at 4, 0. So now as I look at this, I want to evaluate for each one of these things. So what do I get? I'll probably like show the first one and then just step through for the other ones. So here I'm going to again be plugging in my X to my X, plugging my Y to my Y. So I get 5. Actually, I'm not going to do this one because this one's boring. It's the same value. Computer freeze. Oh no. Here we go. 5 times 0. Oops, that should be 5 times 1. Still doing it for the other one. And here we have, that's the weirdest 2 I've ever done in my life. 2 times 9. So here I have 5. Here I have 18. 18 plus 5 is 23. From here now, I'm going to do all the rest of the points. So I plug in 0, 0, I get 0. If I plug in 4, 4 times 5 is 20. 20 plus 2 times 9 is 18, gives me 38. Pretty good candidate there. And I have 4, 0. 4 times 5 is 20. So now I have my maximum right here, which is my 38. And I have my minimum here, which is my 0. Any questions on this one?
How did you get 0, 0?
So 0, oh my goodness. How do I have 0, 0? This should be 1, 0. Can't even read my own work. That's a good catch.
Got you.
Good catch. I'm 100% blaming the Rona, and I'm blaming the heat. There we go. Plug in 1, plug in a 1, spits out a 5. How's that better?
Yeah.
I agree. I agree, 100%. Bonus points to Reese. Any questions here? Perfect, perfect. So now we're going to jump into solving some of our free variable equation problems. These ones are long. There's no way around it, right? These take us a little bit. So when we're doing them, we try and find kind of the easiest route to go. So here I'm looking at 2 for x's, 4 or negative 4, you know, positive or negative doesn't matter as much, but basically I'm looking at 2, 4, and 3. Here I have 6, 2, and 10, and I have 2, 5, and 2. So I'm trying to think which of these is going to combine together nicely. So I have to do like the least amount of work possible. To me, the best candidate here seems to combine my x's. 2x to 6, if I just multiply the top one by -3, I'm good to go. And then I can just use the top and the bottom equations, and they're already set up to cancel out. So personally, let's see, Mr. G would choose X to eliminate. You don't need to, right? I mean, follow your heart. If you want to eliminate Y's, go for it. It's totally doable. You want to eliminate Z's, go for it. Totally doable. I'm going to do it with the X's here. So I'm going to be using the first and the second equation. Actually, I can make my life even easier. I can just do the first and the third, and I'll do the second and the third afterwards, trying to make the least amount of work for myself. So let's do the first one in orange here. I'm just going to first and foremost rewrite them. So I've got 2x minus 4y plus 3z equal to 1. Now here I have negative 2x plus 5y minus 2z equals 2. So before I go any further, I need to look to see what do I have to do to eliminate my x's. Wow, nothing, literally nothing. These are already set up to eliminate. I always recommend people try to use addition here. If you want to do subtraction, like if you want to do like just multiply the top one by 3 and then just do you know, the top one minus the second one, you can do that. It is not wrong. I just see way more people make mistakes more often doing it that way, so I advise against it. It's totally up to you. So in doing this, I've already eliminated my x's, which is pretty sweet. That's by design. So now I'm looking here, I'm saying, okay, this is going to give me 1y, which I just write as y. And then over here I have, excuse me, 3z minus 2z, which is just going to give me z. I have 1 plus 2. Last time I checked was 3. So the important thing to note here is I've just taken 2 3-variable problems and I've turned it into 1 2-variable problem. I'm going to do the same thing with green here, except for I'm going to need to do an additional step. So I'm going to start out by just writing it out again. So 6x plus 2y plus 10z, it's a lot of z's. And this is the terrible thing about z's. Sometimes they look like 2's if your handwriting is lackluster like mine is. And here we have our negative 2x plus 5y. Mr. G, could you write any slower using a mouse? The answer is no. I'm trying my hardest, and this is as slow as I could possibly go. All right, so now as I look at this thing, if I just added this together right now, I just said like, okay, do it, push it through. It's not going to help me. I'm going to add these up, and I'm going to get 4x, 7y, 8z, 21. Doesn't help me eliminate one of my variables. So to eliminate the x's, again, I want to go for x's here, I need to change the way this looks. I can't actually change the problem, but if I multiply the same value on both sides, I can change the way it looks. I'm going to multiply it by 3 because I would really love for these to add up and cancel off. So what's common between 6 and 2 is 6. So I'm going to multiply this by a 3. One's going to be positive, one's going to be negative. That's exactly what I want. So I'm going to hit this thing with a 3. That one will turn into negative 6x plus 15y minus 6z equals 6. I'm going to simply copy down my equation from before, okay? So the thing I had before, and I didn't change anything about it, I'm going to just copy that one just like a wizard here and get rid of that. We're good to go. So now I'm going to be adding these two together. So now I'm taking the negative 6x and the 6x, and they're going to cancel off. I'm going to take my 15y and my 2y, it gives me 17y. Now I have my negative 6z and my 10z, which give me 4z. And it's going to equal 25. So from here now, I'm going to take my two variable equations and work with those. So I'm going to scroll down, give ourselves some more room here. So let's take it here, take it here. And again, I want to avoid fractions pretty much at all costs. So what I'm going to, and not because it's right or wrong, just because people make more mistakes that way. You can absolutely do it with fractions. So looking at it now, I'm saying, okay, well, I can do the top thing times negative 17 to cancel off with y's, or I can do the top thing times negative 4 to cancel off with z's. I'm just going to go the less scary route, which is going to be the negative 4. So I'm going to take the top. I'm going to do the same thing we did before. So I'm going to keep it in orange. I guess that makes sense, right? I'm going to take this and I'm going to hit it. Well, maybe I'll represent it this, right? I'll hit it with the negative 4. Hopefully this is clear enough like this. And it will turn into negative 4y minus 4z equals negative 12. From this point, I'm again just going to copy down my other equation here. Sometimes you need to change both. So just keep in mind, you know, the one we're dealing with, I need to change the top but not the bottom. Sometimes, like if this was like, you know, 13y and 17y, there's nothing common between those. So I'm going to have to just multiply the two together. And that sometimes is what happens. Those are our kind of messier ones. So now let's add these things up. Let's choose a new color here to represent this. So now I'm saying my negative 4y and my 17y give me a positive 13y. Here my z's cancel off. And now I got equals 13. Oh my goodness, this is so nice. Divide by 13 on both sides. My y value equals 1. I now have one of my answers. I want to plug it back in. I can plug it back into orange or green. I'm going to choose orange because I'm lazy. So I got this equation being rewritten, but instead of using y, I'm using 1 because I know y is 1. So that's coming from this right here. So now I got 1 plus z equals 3. I'm going to do some real groundbreaking mathematics here and subtract 1 from both sides. So my z value equals 2. Once I know my z value and I know my y value, I can solve for my x value. So I'm going to jump back up to grab one of my 3 variable equations. It doesn't matter which one you grab. I'm grabbing the top one because I'm just grabbing one. So let's slap that down here and fill in what we know. So I'm just going to rewrite this. I'm going to call this our 2x minus 4 times our y value plus 3 times our z value equals 1. We said that our z value here was 2. And there we go. And we said our y value is 1. So this turns into 2x minus 4 plus 6 equals 1. So negative 4 and 6 is going to be positive 2. I'm going to subtract 2 from both sides. X equals negative 1. Divide by 2. And my x value equals negative 1/2. And I'm done. Any questions on this one? So I have my x, negative 1/2, my y 1, and my z 2. To check our answer, we should take the answers for x, y, and z and plug it not only into 1, not only into 2, but into all 3 of our original equations. That's how we would verify our work is correct. Any questions on this one? Perfect. The next one is basically the same thing all over again, except for maybe we run into another issue with it. If I look at these 2 equations right here, and I take the x's and add them up, and I take the y's and add them up, the z's already cancel off. It's going to give me 6. Can I simplify this equation here? Yeah, I can simplify this. So if I wanted to, I could turn this into x plus y equals 3. And if I wanted to, could I take my second and third equations like this and just add them up with my z's canceling off? Absolutely. So again, I'm eliminating z's here. So here I get 3x plus 3y equals 9. And then could I simplify this thing? Yep. X plus y equals 3. Oh no. What has happened here? Got the same equation, right? So basically this one, if we go through to solve this, it's going to be infinitely many solutions. So what ended up happening here is basically that one of these lines was a duplicate of the other. So we didn't do a lot of like 3-dimensional stuff. But basically, if you think of how on a, whoa, that's not great. On a normal coordinate plane, we could have like 2 parallel lines, or maybe I have a line that is on top of another line. Basically, that's the kind of stuff we got going on over here. So we can take, one of these values, plug it in, and it's kind of like repeated in another one. So that's what we're getting at here in terms of our z value just ends up being 0 here. So if x plus y plus z is 3 and x plus y minus z is 3, then our z value is 0. So that 0 makes it a little bit tricky because then we just have our same equation again. So this just simplifies. And so this is a little bit of a tricky one in terms of like a final answer here. So we'd say infinite solutions. The way that we would figure that out is we'd say, okay, well, this thing, subtract this thing, will give me like a 0 equals 0 scenario. If 0 equals 0, that's infinitely many solutions, or you could also have like 5 is equal to 5. Like all of those are infinitely many solutions. If you got something like 2 equals 4, that's no good. That's no solutions. So we can have infinite solutions. That's totally fine. Just know that on a test, I'm probably not going to throw something like this at you because we didn't spend a ton of time doing stuff like this. But it is good to know. Any questions on this one? Perfect. All right, I'll stop our recording here.